Okay, welcome to CyberOptics stand here at SMT Connect. I'm joined by Sean Langbridge, who's the European Sales Director. Nice to see you, Sean.
Trevor, good afternoon. Good to see you as always.
Good. So, it's a year or so since we've had a look at CyberOptics equipment. It's, I have to say, it's some of the best engineered equipment in the business. It's always nice to look inside one of these. This is the SQ3000. One of the great things about it is its versatility. Tell us a little bit about its capabilities.
Certainly, Trevor. So this SQ3000, which we're now marketing as what we call a multifunctional 3D measurement machine. The reason it's multifunctional, we can support many different applications with a common sensor, common software setup. For example, in this machine that's carrying our standard sensor, the MRS300 at 10 micron pixel, we can support 3D SPI, 3D AOI pre and post reflow, 3D AOI full measurement capability, and what we call now CMM, so coordinate measurement machine. So we can measure plastic, metal parts, anything physically we can fit in the machine, we can measure.
What about coatings?
Again, coating, if we can physically see it, we can measure it. So, yeah.
So of course the strength of CyberOptics has always been in your sensor. As you say, this one here's got an accuracy of plus or minus 10 micron. I believe you've also got some in the semiconductor field that are going even better than that.
Yeah. Well, the pixel resolution is at 10 microns. The height resolution is half a micron. Okay. So we can actually measure or detect a difference of half a micron in the height. So it is very precise. Right. And as you just pointed out, we are looking at opportunities in what we call package inspection or back-end semiconductor for this system. We also have a higher resolution sensor at 7 microns, which we're using on some of our CMM applications. There we're measuring CPUs, for example, processors, packages, wire bonds, very, very fine wire bonds, very accurately.
Excellent. So, you know, you're following that track, you know, the merging of the technologies from SMT through into back-end packaging. Let's look at the size of the board and the size of the assembly that you can measure. What is your maximum board size and what's your Z height?
Well, on this one, speaking about the sensor capabilities, so the distance from PCB or the clearance is 50 millimeters, but the 3D measurement, so the measurement we're able to take from board level or substrate level to the maximum height is 24 millimeters in full 3D. So it's quite high. So we have got a very high range, so we can do board level, very small features, 0201 metric or even smaller, very accurately, but also tall connectors, tall electrolytics on the same board, and that obviously plays into the flexibility again of the system.
Absolutely, absolutely. So, again, as I said, the engineering is always very high. You're using linear motors, which gives you a pretty good accuracy that way as well, and speed, of course. And also no moving parts in the head.
That's right, that's been one of CyberOptics' main differentiators and I believe advantages over many years. Starting with our first SPI machines in the mid-90s, we were the first company to develop no moving parts in the sensor, so fixed optics, and that's still the same today. No calibration, no moving parts, very little or zero maintenance at all on the sensor.
Make it very easy to come and set up like a show like this.
Absolutely, yeah. 4 screws and you're finished, Trevor, that's it. Yeah.
Okay, well, great. Well, thanks for giving us an update on what's happening here at Cyber, Sean. Nice to talk to you.
Good to see you as always. Thank you.